Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. This is Meetup number 104. Every week we look at Python issues, and we're really aimed at beginner Python users. So feel free to ask any questions. I'll be watching on the YouTube chat just to the right of the video you're watching now, and also on our Slack channel. There's instructions in the comments below on how to join our Slack channel, and it'd be on the Learning to Code channel in Slack if that's where you decide to put your comments. Alright, today we'll be looking at some real-world problems. So I've come across a few issues when working with pivot tables and how to save in pandas, and how to save pandas data frames to spreadsheets and bring them out again, and the issues to do with time zones, and they're all really to do with the same sort of issue. So rather than a theme based on the technology, this is a theme based on a real world problem and the sort of things that can go wrong. We'll be using Google Colab, so it means you don't have to have Python installed on your computer, and I provided a link below the video to Google Colab. So I invite you to click on that link and open up a Jupyter notebook in Google Colab. I've got a few people who've been coming back week after week, so they'll understand a lot of this, but if you're a first timer, feel free to ask questions, because we really, as the beginners, are the most important people watching this, and so we need to make sure that you don't get left behind. And I'm happy to go back over everything, take it to the simplest detail. Okay, we've got our Jupyter notebook here. I'd recommend you click on this button here to copy it to your own drive. You need your own Google account to do this. So we'll save it to our own drive, and so you'll create a new one. And the new one will have a new name. It'll be called Copy of Meetup 104. And what I'm going to do is I'll share a link to this notebook as I'm working through it in the video, so you can use that link to get updates of anything that I've typed into it. So anyone with the link can view it. You're all viewers, and I'll post this into the YouTube chat and into the Slack channel. All right. So one of the things we're going to be looking at is data from electricity generation in New Zealand, and so I've provided a link here to that, and that's what we'll be working through it all the way through. A lot of the problems that we're going to have tonight are to do with different versions of things. So we're going to use we'll have a look at what versions are installed in Google Colab. So Google Colab comes with a lot of the libraries that come with Anaconda, and to run any one of these cells, we click on the play button, and the hash sign means comments, so they don't get run. That's just saying what's going on, and the exclamation marks actually means run from the command line. So these aren't even in Python, these are going back down to the command line. So we'll run that, and this is a command line that's using pip, which is the package installer for Python, and we're going to list our existing packages that come with Google Colab, and then I'm going to filter it using egrep, which is a command line tool, to see which ones have got, to see if we've got pandas, which we do, xlrd, which we have, which is version 1.1.0, xlwrite, we've got version 1.3, xlsx writer we don't have, odfpy we don't have, and openpyxl we've got 2.5.9. So I'm going to run the same command again, but this time I just check which ones are outdated, and we can see here that all of them except xlwrite are actually outdated. There's newer versions available. So we are going to update xlrd to version 2, and we can use that using the pip command install -u or -- upgrade, xlrd, and we also want xlsx writer, and we also want odfpy. So I'll install them from scratch. They don't exist yet because they don't come with Anaconda. And this one, xlrd, we want to use the latest version of xlrd. So I'll run that by typing Control-Enter. If you see me do anything on the screen that you don't understand, then maybe I've done a keyboard shortcut. Just ask the question and I'll let you know what it is that I've done. But I'll try to tell you what I'm doing them at the time. Okay, so let's have a look at what's happened here. Successfully uninstalled xlrd 1.1 and installed 2.0.1. And we've also successfully installed odfpy and xlsx writer. So these are all to do with reading and writing Excel files from Python and pandas. Now when we use Python, we like to use different libraries. We're going to use the datetime library, which is a standard library, and we're going to use the pytz library to get time zone information, and we're going to get use pandas. And pandas we like to abbreviate to PD just so we don't have to type so much. So pytz and pandas are both third-party libraries, so we need to install them, and we did check up here. We didn't check pytz, but we checked pandas, and pandas is installed. Datetime comes automatically, so we only need to import that one. We don't need to install it first. Right, so let's have a look at the data that we're going to be using. We're going to get this data from the New Zealand government website. So I'll just open this in a new tab. We're going to be looking at generation data, mainly wind generation data. And we can see it comes in every year and month, so year 2021 and the month 03, and gives us this generation data, and they explain daylight saving. We will come back to that soon. So I've grabbed the URL for April 2020, and I've chosen April on purpose because that's the month they turn off daylight saving in New Zealand. And unfortunately 2021 data is not available yet because we're still in April, but we use last year's data. So that's the URL, and if I run that, it'll read all the CSV data that's available at that URL and put it into a data frame. So let's have a look at the data that we get. So we've got a few things here. We've got site code, a point of connection code, network code, a generator code, a fuel code, and a tech code. So what we'll be looking for is wind data that's come from, and we'll have all the wind generators in New Zealand and where they connect to the network. And we're not interested in this other stuff. And let's see how they've done the data. This is all kilowatt hour data for each half an hour during the day. So on the 1st of April, we've got the first half hour, the second half hour, the third half hour. And I thought that was a pretty weird way of laying out the data, but I can see why they've done it, because they're actually using daylight saving time. Now, I'd really recommend, if you've ever got a server, don't ever use daylight saving time because it is so complicated. But they've decided to use it, and how are they going to solve the problem? Because on the 5th of April, the first Sunday in April in 2020, they had to switch back from daylight saving to standard time, and so there were 25 hours in the day. And the way they've done that, they've put in 50 time periods, 50 trading periods, each a half hour long, and on the 5th of April you can see there was an extra values for kilowatt hours for those 2 half hours. All right. Now, what our overall objective tonight is to rearrange this data into a format that's closer to the Australian format in their AEMO data, and AEMO fortunately uses Queensland time, so it's doesn't have any problems with daylight saving. So we'll have a time column, which will be the index, and then we'll look at the different wind farms and where they connect into the network. So TWF12 is a big wind farm, stages 1 and 2, and TWF3 is the stage 3 of the wind farm and where they connect. And these are all the kilowatt hours that have been produced in each of the time periods. And I've used UTC time here, and you'll see later why we've had to do that. So our steps tonight, we're going to find just the generators that use wind. We can convert those TP1 to TP50 columns into rows. We can convert the times to UTC to remove that ambiguity of daylight savings time. We'll change the index. If you look back here on the index, it's the first column. It's just 0, 1, 2, 3, so that doesn't really mean anything. We'll be using our UTC time as our index. Get rid of the unneeded columns, save it to Excel in a formatted way, and read it back from Excel. All right, so think about how you might want to tackle this. You know, when I before I had much experience with data frames, I'd look at this data and I go, okay, I need to loop over this one row at a time, and each row I'm going to have to loop across each of these columns, and each time I'm creating a new row in my new data frame, and do it all manually in Python. But we'll look tonight to see if we can find some better ways that some of the capabilities that data frames have for changing that format. So we've read the data into our variable called dfraw, and we've looked at it. So let's see what type that is. We'll just use the Python built-in function type to find out that it's a data frame from pandas. And one of the things we can do with data frames is we can pull up individual columns, like we can look just at the fuel code column by using square brackets and the name of that column that we want. And what that does, the type that returns, is a series. So a series is like a single column of a data frame. It's still got an index, but it only has one column. Okay. So for that series, we can find just the unique values. So let's have a look at what fuel codes we'll find amongst all the generators in New Zealand. So we've got hydro, so that's water coming out of a dam, or water flowing down a river and turning a turbine. We've got wind, gas, coal, geothermal, wood, and diesel. Now we can look at the tech codes, the technology that they use. So there's hydrogen, wind. They use cogeneration, which is generating heat and electricity at the same time. They're using thermal power, or they're using geothermal power. We can also look at the names of all the generators. So there's the generators. Some of them are wind farms, so we only are interested in the wind farms. Look at how many networks there are and how many points of connection. So plenty of points of connection. So that's really just to give us an idea of what the scope of the data, by just finding the unique values, and what we're going to have to do to clean it up. Okay, so we want to find wind. So do we use the wind fuel code, or do we use the wind tech code? Not really sure. So let's have a look at this group by on a data frame, and group by will find all the different combinations of fuel code and tech code that there are. Now, fuel group by itself just returns a pandas data frame group by object, which is not much useful, not very useful. But if we call size on that, it goes through each combination. It actually creates an index here, and then tells us how many of each. So we had 30 combinations of coal and thermal. We had 30 combinations of diesel and thermal, 120 combinations of gas and cogen. And remember, we're doing this for April, so there's 30 days in April, and that's why most of these are a multiple of 30, because there'll be just one coal power station over there that's producing thermal power. 4 gas using cogen, 5 gas using thermal, 11 geothermal, quite a number of hydro plants, and obviously some of those weren't running on every day, so we didn't get a multiple of 30 there. We've got 9 wind farms and 3 wood co-generators. So it looks like we could just, gas has got a couple of tech codes, and thermal tech code has got a couple of different fuel codes, but for wind we could use either fuel or tech, and we just get those, just the wind ones, so we're okay. I think we'll just use the fuel code. So we're going to use data frame filters. If you haven't seen data frame filters before, let me know and I can run through them a little bit more. But what we do is we just run this. Pandas overloads the equals operator, so that df raw fuel code equals wind goes through every row in the fuel code and just returns a whole bunch of trues and falses, and the trues are where it equals wind and the falses are where it doesn't. And you can pass that array of trues and falses into the square brackets of df raw, and that will give you just the rows of the data frame that are for wind generators. And we can store that into a new data frame, which we'll call df wind, and we'll look at head to look at the first 5 rows of that to just check what the data looks like. Okay, and that's looking good. Each row is different by different trading date, but we're getting there our wind farms. So we've done one of the first steps, which is just filter out all the non-wind farm data, and we've got just the winds. Okay, so task 1 for tonight is going to be unpivot the columns TP1, TP2, TP50. So they're these ones along here. And what we were trying to do is rotate them down so that they come down onto separate rows. So here's an example of what the data we want it to look like. So we're going to create a new column called trading period, and in there it's going to be whether it's a TP1, TP2 up to TP50, and a new column called kilowatt hours, which will be the value that's underneath each of these columns. So we're going to have 50 times more rows, but we've got a lot fewer columns in our new data frame. So the way we're going to use that, the way we're going to do that is we're going to use the melt method on a data frame. So if we'll use Jupyter Notebook here, can give us the help on any method by putting a question mark and the name of the method there. And notice I didn't put any parentheses at the end because we want the name of the method. If we put parentheses there, it will actually call the method, which is not going to work for us. So I'll run this cell, and over here on the right we can see what we need to know about melt. So let's start trying to do it. So we're going to start with the wind data frame, and we're going to melt that. And so ID vars. So we want everything here, which is going to, what do we say, to use as identifier variables. So they're the identifiers for the rows. So we're going to identify by point of connection. So let's, I'll use named parameters in when I call a function. We'll provide a list. So we want point of connection code. We want the generator code. And really in this output here, it's these 3 that we want: point of connection, generator, and trading date. Okay. So that's provided the ID, the value vars. So value vars, if we look over here, is a tuple list or array of all the columns we want to unpivot. So that's TP1 all the way up to TP50. Okay, so we'll have a list of those. I haven't created it yet, so let's just call it list TP. Value vars, var name. So the TP1s are the vars, the TP2s, and the name we're going to call that column is trading period. And the next one is value name. Because this data is kilowatt hours, I will call it kilowatt hours. Value name equals kilowatt hours. Column level, if columns are multi-index, they're not. There's only one row of columns, so they're not multi-index, so we're going to ignore that. Ignore index, the default is true. Ignore the index. Our index here is 240, 241. We're not interested in those numbers. They don't mean anything to us, so we'll accept the default there. All right. So I'll hide this a bit. Now, the one more thing we need to do is create a list of our trading period names. So let's start with an empty list. In range, we want to go from 1 to 50, so I'll also range 51 because it goes up to but not including the last number. We're going to append that column name, which is going to be TP followed by the value of I converted to a string. So I is an int, and we're going to convert that to a string. All right. So let's just print out our list TP as well to make sure it's what we're expecting. And so we'll run this. This will do the melt. We're not storing the result anywhere, but we've left it as the last line in the cell, so it'll display that result for us in Jupyter Notebooks. So here you go. We printed out list TP, and that looks good. TP1, TP2, TP3. So that's what these 3 lines of code have done. Have created our list of trading period names, and then we've done the melt. We've got our ID variables. We've got our value variables here. So there's the name of that is trading period, and the name of the values is kilowatt hours. That's exactly what we wanted, except we've got all these NANs, which stands for not a number, in there. So that's the blank data for all those days that are not changing daylight savings. So we want to get rid of that as well. We'll use the method drop NA. And if we look at the drop NA here, it's a method on a data frame. Axis just says we want to drop rows, so it'll be axis equals 0, and how equals any. So how any means if any data in the row is a NAN, then drop the row. All means all data in the row has to be NAN to drop that row. Threshold, we're saying how many NANs we want. We'll just go with none because any is all. We're going with any NANs. Subset, the labels to consider. I guess we could just say kilowatt hours, but it really all the others. It could be anywhere. So we'll just go with the default values. In place equals false. So to call a method, what we've already done creates a new data frame, and so we can call the method drop NA, which then creates another new data frame based on the previous new data frame, but with the NA is missing. So let's run that, And there we go, we've got some TP50 still, but they're the only ones that have actually got data in kilowatt hours. And you can see they all happened on the 5th of April. All right, so is this making sense? You're understanding what we're trying to do here? Let's have a look at the solution. So the solutions are pretty similar. We're running melt and storing the result into a new data frame called df 30 minutes. So it's just data every 30 minutes in each row. The value vars, I've done that using list comprehension, so I've saved myself 3 lines of code by doing that. I've used format strings rather than string concatenation and converting ints to strings. So that's another way of doing it. And everything else is the same. So let's have a look and see if that gives us the same result. Yep. So it's a really good idea to have a go at these exercises. If you want to do it during the video, just pause the video, because I'm just going to go straight on to the answers. But pause the video, have a go at it. Then when you've finished having a go, look at the solution, and you can play the video, maybe play the video at 1.5 times speed so that you can catch up to the live with us again. All right, this looks like it works. Let's check a little bit more data. So we'll check we'll just run some filters. Trading date the 1st of April, and gen code equals TWF12. Okay, and let's have a look what we're trying to match. There's this one here. Actually, they're all zeros, so let's do the 2nd of April. So we get 773. Oh, okay, and TWF has actually got 2 points of connection. So the data we got above is just BPE 0331. So we're going 773, 507, 400. And let's have a look. 773, 507, 400. So yep, we're getting the right data there. It's done all the unpivoting just as we expected. So there we go. We've learned how to unpivot some data and put it into rows. Oh, we'll do one more check here. How many days use TP49? And for that generator code, and there's only one day, both as the 5th of April is when TP49 was used, and that's the day daylight saving ended. Okay, so this is the way I generally like my data, because I come from a database background, so I'm not used to having these doing work on basically pivoted tables, like having all the TP ones out to the side. I like to be able to run queries where I can say, give me all where this value is this and this value is that, or the trading dates between this value and this value. We've got trading periods here. Later we'll convert these to times, and then I can and just one column, and that makes it a lot easier to do filters. Okay, that introduces us into Python time zones using datetime and PyTZ. Okay, so when you create a datetime using the datetime library in Python, and this method here does it by parsing a string to catch the time. All right. Okay, so Leo says he falls behind and it disappears up the screen. Remember, if you've got that link that I gave you, you can grab anything that I've typed. I'm not actually typing too much different to the solutions as they are, so there's not a lot of stuff that you need to catch up on. And really, I'm just running cells that have got stuff already in them. But try to understand each line in the cells that have got code in them. All right. Yeah, so we're parsing this time, and that's the value we're going to parse, which is midnight on the 5th of April. And we've just put in a format here to say that it's going to be a 4-digit year followed by a dash, and a 2-digit month followed by a dash, a 2-digit day followed by a space, a 2-digit 24-hour clock hour followed by a colon, and then a 2-digit minute. And the date time that we get from this is going to not know anything about time zones. So I'm just going to, we'll print it out. So that we can see what it looks like. And then if we want to put a time zone on it, we use the PyTZ library, and pytz.timezone, we choose our time zone that it's in, which is, so New Zealand time is in Pacific/Auckland. You have to know these. I mean, you could look up the list of time zones in PyTZ if you need to find out what this is. And then that has a method to localize a date time and return the new date time. So let's print what we get there. All right, and then I've got a list. I'm going to so I'm going to print out all these columns, each one with 28 spaces of format. So I just did that in a loop just to make it easier having to type all these formats. Then print a new line, because that's printed without a new line, and then I'll do 30 rows in my table, each one an hour apart, starting from midnight. Let's just run that and see what it looks like. So date time is our date and time which doesn't know anything about time zones, but it's midnight on the 5th of April 2020. And so you see the format that they use is very similar to the format that it's come with. It's just using 00. It shows minutes as well as seconds. It shows seconds as well as minutes. Date time NZ, so that's after we use the PyTZ library. You can see it now adds an offset onto that, and so we know what time zone it is. So we've now done some arithmetic, and what we're trying to do is get different hours of the day and just see how they handle daylight saving. So we could start with our New Zealand time zone aware date time, DTNZ, and we can add in the number of hours for the rows we're in. So the first time through it'll be 0, then we'll add 1 hour, then 2 hours, then 3 hours, and we'll display that value DTNZ1. And you can see here it is, New Zealand time plus delta. So there's a time with 0 hours added, with 1 hour added, with 2 hours added. So it's all looking good. But when we add 3 hours, we get this time of 3:30 in the morning plus 13 hours after UTC. So that's not a really useful time format for us, because at 3 a.m. the daylight saving was turned off. So what this should really be saying is 2:30 plus 12, because it's now in a different time zone. So we can see that by adding a time delta to a date time that's got time zone awareness, that it just keeps the same offset, the 1300, ahead of UTC. So while they're correct, they're not much good to any user reading it, because the user's not going to be expecting these times to be, which are when we're back to standard time, to be 13 hours ahead of UTC. And they're not much good for the programmer, because there's all this time zone information that he's got to try to keep track of. All right, so let's have a look at, maybe we could just pull the time zone off, and here's the way you can do that. Replace the time zone info with none, and that'll make a time zone aware time into a time zone naive time, and that gives us these times, but that jumps, well, we don't know anything about it, it's time zone naive, but if it was in New Zealand, we'd have a 2-hour gap here going from 2:30 to 3:30, which is just not correct. So that's not much good. So let's try converting that naive time back into New Zealand time, and we're really trying to get this offset to be right, and it does sort of work. Like midnight does give us 13 hours ahead of UTC, and 2:30 gives us 12 hours ahead, and 3:30 is 12 hours ahead. So that's sort of okay, but once again we've got a 2-hour difference between 1:30 plus 13 and 2:30 plus 12. So I hope you're feeling the pain here. The purpose of this is to show you how much of a headache daylight savings is. When you ever get a chance to vote against it, vote against it. I've got no problem with people changing the work hours, but don't touch the clocks. All right, so that didn't work too well, but let's try converting to UTC time from this first column, New Zealand time plus delta. And we do that by running this pytz method. Well, in fact, it's as time zone, so it's in the date time library, and it takes the value in the column 1, converts it to UTC time by applying that time zone and giving us a new date time, which I've labeled DT UTC because it's in UTC time, and that's what we're getting here. And this is starting to look pretty good. Oh yes, the UTC is this one here. This is starting to look pretty good. It's midnight on the 5th of April is actually 11:30 a.m. on the 4th of April in UTC time, and we can see we've got 1 hour going up at every time, and we've got no ambiguous dates and times here. If I forgot to show you, I can just quickly show you now the electricity authority, how they talk about daylight saving, and they do this by explaining how the trading periods work. We've got our normal times, the trading period in standard time, half an hour past midnight is that time, and that all looks good. And in daylight time it's 13 hours away from UTC, and then they have to give us a whole special table just for the day that daylight saving begins, which we're not interested because that's in September, I think, and another whole table for when it ends, and that's the one we're looking at. And this is where all the problems happen, because in New Zealand we have time 2 to 2:30, 2:30 to 3. We'll look at this one, 2:30 to 3 in trading period 6, and trading period 8 is also 2:30 to 3. So if someone tells you it's 2:30 on the 5th of April, you don't know whether they're talking about trading period 6 or trading period 8, and they're the two times and the offsets from UTC. All right. Oh yeah, so we've our UTC from New Zealand time plus the delta, which was this converting that to UTC, worked really well. And now if we convert the UTC time back to New Zealand time, we get exactly what was in the table. 5th of April, half past midnight plus 13, half past 1 plus 13, half past 2 plus 13, half past 2 again plus 12, half past 3 plus 12. So this works well. It gives us the times as people would expect in New Zealand, and so that's how we've managed to get New Zealand time for each of those half-hour periods during the day. And our time delta tells us how far we are from that start, which is 0, 1, 2, 3. So just working backwards is a double check. That seems to have worked. All right, so create a function, UTC from date and period, which takes the date and period as a string and returns a date time object in UTC time zone. So I might just clear that so we can see our functions up above. So to define a function in Python, we define it with the def keyword, and the name of it's going to be UTC from date and period. And so we're going to pass it in 2 arguments. One's going to be the date, which was called D, and one's going to be the period, which we'll call P. So our date, we can that's a string. D is a string, so we're going to parse that string. So we'll use our date time library, and we'll so date time is the name of the library. In there is a class called date time, and that's got a method called string parse time. And we put in the string that we're going to parse, which is just going to be D. And we put in the format that it's going to be in. So it's going to have a 4-digit year, followed by a dash, followed by a 2-digit month, followed by a dash, followed by a 2-digit day. So that DT is a time zone unaware date time. So now we can convert that to a time zone aware. And the way we do that, as you can see up here, we take Pi time zone library, and the time zone we're going to use is Pacific Auckland. And we're going to localize that date time that we've already created. Okay, now we need to know, we want to add the time delta onto that based on the number of periods. So the number of periods after midnight is we're going to take the period, which is going to be something like TP6, and we're just going to look at everything after the first 2 characters. We want to strip off the first 2 characters. So after P, we can use string slicing to do that, and we want everything from the second character, or the character index 2 onwards, which is really the 3rd character onwards, and then we can convert that to an integer. So that'll be 1, 2, 3, 4, 5, 6 up to 50, and then we're really looking at the number of periods after midnight, and so we have to subtract 1 after that because they started counting at 1, and the first one we really wanted to be 0. Okay, so we can add in the periods, so the DT NZ with the period, or I'll just call it with P, equals DT NZ plus, and we'll use from the date time library, the time delta. So these methods I all used above, so you can see how they worked above, so I'm just doing the same thing again. Last time we did hours, we're now dealing with half hours, which is really just minutes times 30. So the number of minutes is going to be 30 times the number of periods. And that gives us basically our first column. Now we're going to convert that to UTC. So I can just return the value from here is going to be DTNZ with time periods dot as time zone. Now, remember before when we wanted the New Zealand time zone, we had to say dot time zone and then pass a string, which was the name of the time zone. UTC is such a common one that it's actually got its own attribute, a constant there. We can just say pi time zone dot UTC. And that's all we need. All right. So let's run a test, maybe on time zone 6, time period 6. So time period 6, the result is 4th of April, which is correct, at 13:30, and time zone is UTC, which is +0. So yep, we got the right answer. So there's a solution to the task. Let's have a look at the actual solution, which I didn't even label as a solution, but anyway, this is the actual solution provided. Very similar. So we converted to the UTC time before adding the periods, and then it added the periods to the subtraction here, and actually multiplied outside of time delta. So it's just the time delta here was just minutes equals 30, and then multiplied time delta by the number of trading periods, time periods -1. So that works as well. So let's look. That one prints out all the answers, and they all match our test data up here. So we've got it all correct. So is there any questions there on how to handle time zones? Right. Well, let's get into something funky. We'll create a new column called UTC time based on the trading date and the trading period. Now, once again, the first time I look at that, I'd go, oh, well, I've just got to loop through every row in my data frame and calculate the trading date and trading period into a UTC time, and then fill that data into that row and column in the data frame. But if you look carefully in the data frame documentation, you'll see they've got this function apply. So let's have a look at the help for apply and see what it can do for us. So it's just showing up over here. So objects passed to the function are series objects. Okay, the final. Okay. Oh, here we go. Apply a function along an axis of the data frame, and that's what we want to do. We've got our function, and we want to apply it to every row in the data frame and save the result in a new column of the data frame. So let's apply it. So we've got our data frame as every 30-minute data. We're going to apply a function. Now the function that we apply is going to apply to each column or row. And so here we go. If we say 1, we apply the function to each row, which is what we want to do. But it means that the parameters going to the function have to be rows. They can't be individual pieces of data as we've got here. So here we've got string data, string date, and string period. But our function needs to just have one parameter, which is the row. So let's we'll create a new function. We haven't created it yet, called apply UTC. And now when we're passing a function as a parameter to another function, we don't call it, which would be putting the left and right parentheses in. We just leave the function name there and it works just like a variable. We can pass functions around and then they can be used. It's a very powerful feature of Python. Okay, axis equals 1, we decided. Raw equals false, passes each row as a series, that's fine. Result type, I think we'll just go with the defaults on those. We don't need to pass any additional arguments to our function, so either as positional or keywords, so we can leave all that blank. Alright, so let's define our new function, which is apply UTC. And remember I said it takes a whole row, so we'll call our variable row. I could call it anything, I'm just going to call it row and make it clear that it's getting a row. And then that is going to call our other function, UTC from date and period. And so we have to give it the date, which is just for the row, which is really like a series. We can use a named index on that in square brackets, and it's going to be trading date, and then the trading period is going to be also look from row trading period. And so if I run that, it returns a series which has taken the trading date and trading period, and that's there all the values in the series. So they look all right. Let's have a look at the solution. I guess the solution does the extra bit, which is actually saving it as a new column in df30min. Everything else looks the same. So let's have a look at what that data frame looks like now that we add the extra column at the end of UTC time. We can check a few different values to see if it got it right. So let's look on the 1st of April for TWF3. And we can see that that's trading period 1 is 11 AM UTC time on the 31st of March. That's correct. 11:30, 12, 12:30, 1300. Looks good to me. All right. So let's save this to an Excel file. And we know that data frames have this toXL method, and you just pass in the name of the file that you want to save. So we just I'll just uncomment that by removing the hash at the front. And run that, and what happens? We get an error, and the error is Excel does not support date times with time zones. So like I said, this is the purpose of tonight's session is really showing you the sorts of errors that can come up, and how we cope with them. So we can't use time zone aware date times. We have to make sure it's time zone unaware. And task 4, I'm just going to, I can leave that uncommented. Task 4, ensure times in data frame are time zone naive by rewriting apply UTC. Okay. So let's grab all this. I'll copy that. And if we look back where we first started looking at time zones, there was this line here when we were creating DTNZ2. That's how we created a time zone naive date time, by replacing the time Z info with none. So that's what we need to do. I don't like having errors in here, so because it means if someone tries to run all the cells in this Jupyter notebook, it'll stop when it gets there and won't finish off. All right, that's about to return that, and all I have to do is tell it to replace times Z info with none. And now if we look at UTC time, we can see that they're the times in UTC, but they haven't got the time zone info, and we know that that's going to be the same for every row, because UTC never changes the offset, it's always 0. So it's quite safe to have a column called UTC time. That means we know that it's going to be in UTC, and we don't have to worry about are there potentially different offsets on different days. Okay, so the solution actually stored the result from that in a variable and then did the replacement on that variable. So that works as well. Any questions? Are you finding this interesting? Because these are real world problems that have to be sorted. Okay, so we're going to, let's just write this out again. And now that worked. We just put in the file name and the name of the what we were going to, how we're going to, the engine that we're going to use. So let's pull the engine out and see what happens if we try using it without saying the engine. Yep, that works as well. Okay, so we didn't need to give the engine there. So Peter says, does it make sense to do everything in UTC? And yep, I'm a very strong believer in doing that. The only thing you don't want to do in UTC is when you're displaying results to the user, because the user is going to have trouble converting all the time back to local time. And some of the times what they're going to want to do is tell me how many kilowatt hours were generated in the month of April. Well, that's the month of April in New Zealand, not the month of April in Greenwich. So in that case, you do have to convert it back to local time for doing those sorts of reports, even though one of the days has got 25 hours, and when you go to September or October, one of the days there has only got 23 hours. So yeah, if you look at my conclusion up here, conclusion here, store times in UTC, convert to New Zealand time when displaying the results. I've seen actually on Stack Overflow, someone's put together a whole lot of recommendations about when to do things, and there's other cases, for example, birthdays. So birthdays you don't convert to a time zone. If someone's birthday is the 20th of April, then it's the 20th of April regardless of what country they're currently in. Vince says, yeah, code equals UTC, end user equals localized time. That's right. And especially when you're doing web applications, you can have many users all in different time zones. So you can either try to infer what time zone they're in from the data in the headers that's coming into the web application, or you can get each user might have the favorite time zone that they like to work in, so you give them a configuration. So they say what time zone they're in, and then you use that time zone whenever you're displaying information for them and running reports even. All right. Okay, so now we're going to look at a bit of the internals in how data frames work and when they're sending data to Excel. And what they do is they call up a default writer. They work out what the default writer is if an engine isn't specified. And this method is called underscore get default writer. And normally if they have a method with an underscore in it, it means you're not really supposed to use it, but we actually want to see the code to work out how they're working out which writer to use. And in fact, in later versions of pandas, they've removed the underscore, so it's now get default writer. But with the pandas that we're using here, that comes with Google Colab, it's underscore get default writer. And we want to look at the source code, so I'll do 2 question marks here, and let's have a look at the source code for this function. So it's a pretty short function, and what it does is it looks at the extension of the file name. So our extension was xlsx, and it's got this dictionary of default writers, and by default OpenPyXL is the writer, but then it looks to see if xlsx writer is installed, in which it is, and if it is, then it replaces OpenPyXL with xlsx writer, and so the default writer in this case will be xlsx writer. So let's run that method, and we can just and print out the result for xlsx, and it says the default writer for xlsx is xlsx writer, and that's because we've got that library installed. If we didn't have that library installed, it would return OpenPyXL. But looking at this, we can see that we can also save to ODS. So if we wanted to create an open document format, which can be used by LibreOffice and OpenOffice, and we've installed ODF-PY, then we can use ODF. So let's see if that works. Taking a bit of time, and that's done. So if we look in our files here, we can see this sample data just comes with every notebook, but these are the 2 files we've created tonight. So let's download and have a look at this. Let's have a look at this one as well. So the xlsx, we'll open that. So I don't have Excel installed on this computer, but I've got LibreOffice. We'll discard that. I clicked the wrong button. Okay, so this is what our data frame looks like. It's a bit hard to see, all the columns are pretty narrow, but I'll just increase them to the default size so that it fits the data by double clicking. Yep, that's done that. So this is using the xlsx format and opening it in LibreOffice Calc. So that's looking reasonably good, but so you know, maybe users are okay with this year, month, day. I like that year, month, day format. We've got different numbers of decimal places. We've still got these columns here. Apart from that, it's not too bad. Let's open up the other one, the ODS. So the ODS looks pretty similar. It opened a lot faster, but it didn't format the dates. So it's easy enough to do. I can select that column and format, and we'll just check that it's got the right data in there. Let's use any of these got times on them. We'll use that format. Okay, so that data looks pretty good as well. So it's faster to open, but it didn't have the dates formatted correctly. So, there's not a lot of benefit in going with ODS, but you might find that in some case there is. So we won't save any changes, and I'll close the other one as well, because our next exercise is going to be reading it back in. So what have we done? We've done that. Yep. So this one here, read Excel. So let's have a look at the help for reading Excel. So remember at the beginning, I upgraded xlrd from version 1 to version 2. So one of the things they've done with xlrd is they've realized that there are a lot of bugs in it. And when it comes to opening xlsx files, and they thought to themselves they can either fix those bugs themselves, or they can just stop trying to import xlsx files and leave that to other libraries, because there's some other much better libraries out there like OpenPyXL. So now in version 2, if you try to read an Excel file through pandas, you're going to get this error. xlsx file is not supported. So you have to specify an engine. And remember, we're using the old version of pandas that comes with Google Colab, but we upgraded xlrd. Now, if you upgrade to the latest version of pandas, the new version of pandas knows not to be looking in xlrd. See what it says here about engine. Okay, supported engines: xlrd, OpenPyXL, ODF, PyXLSB, but the default is xlrd. And back in those days, pandas thought that xlrd supported the old and the new XL5 formats, but it doesn't actually anymore. So we have to specify the engine, OpenPyXL, and when we do that, it works. We get the Excel file reading back in the data frame. Looks pretty close. We didn't specify an index column. I could have specified that, and that would have got rid of this duplication that we've got here with a new index and the old index. But one of the problems that we've got is that these UTC times, when we saved them, they were to the nearest, well, they were to the nearest minute really, but now we're getting microseconds down here. So that's a bit of a problem, because they won't match if we ever try to match exactly on a date and time. So I've came across this this problem myself a few months ago, and I had to write in work out how to work around it, and I prepared this these exercises for you to see how to do that. But since then, OpenPyXL, which is the engine we used, has realized that this is actually a bug. And so in version 3.0.7, which was just released a few weeks ago, they decided that the spec, and I presume they mean the Excel spec, says that these times are saved to millisecond accuracy, and so they shouldn't be taking it down to microsecond precision. And so when we can round this information, and let's have a look. So let's have a look at the data frame that we've read in, and you can see that UTC time is a date time 64, which is a NumPy time, a NumPy format. And NumPy have got a function called round, so they can round to the nearest second, or we can even round to the nearest millisecond or minute. And then when we look at it, it gets rid of the problem. So if you're having problems reading in Excel data files because you've got an older version of OpenPyXL and xlrd no longer works, then you have to do this rounding on any date and time column that you read in. And it's probably only now that because xlrd has refused to read xlsx files, that everyone started using OpenPyXL and suddenly seeing this error, and that's why it's just got fixed recently. All right. So do this rounding. You could do 1 second. You could do 1 min if you wanted to do minutes. So moving on. What are the New Zealand wind generators? So let's have a look at the generator codes in DF30min, and just the unique ones. So there should be 7 of them, and there are. All right. Now we want to pivot the data frame. So remember we did melt before, which was unpivoting. Now we're going to pivot using the method pivot for each wind farm and point of connection combination. And we want the index to be UTC time, which is that extra column we've created. Okay, let's call up the help for pivot. And that doesn't look too hard. Let's have a look at our data. I'll close this so that we've got more space. So we've got a point of connection code, gen code. All right, so we take our data frame and we call the pivot method. So you see here the signature pd.dataframe, that's the type of the class, that's the class of the object we've got. So dataframe.pivot is the method name, so we can call it just by using .pivot on any object of that class. The index we specify, so we just call that UTC time. The columns, so we've got a point of connection code and a gen code. And the values. So trading date and trading period, we're pretty happy to drop them. We don't need them anymore because we've got the UTC time column. The values is going to be kilowatt hours. And we don't need the existing index, we'll just create a new index with UTC time. So let's have a look what that looks like. So it's created there we go, it's even labeled at kilowatt hours. These are our point of connection codes. You see this point of connection code here, TWC2201, has actually got 2 wind farms attached to it. And yeah, that looks good. And there's all the data, so that's pivoted it out. Let's have a look at the solution. The solutions are pretty similar. Only difference is, so it's got gen code and point of connection code round the other way, which if I remember, that's what we originally set out. We wanted the gen codes to be above the point of connection codes. The values, it's just put in kilowatt hours as a string rather than a list. So let's have a look at what that looks like. So it doesn't actually label kilowatt hours at the top here of these column names. TWF12 connects to 2 different points of connection. So this is called a multi-index. It's like a hierarchical index column names. And we can save that to Excel. We'll just use OpenPyXL to do that. And let's have a quick look at what that looks like. So it's preserved the structure of those multi-indexes. Let's make these column widths a bit more readable. So it spanned columns to for these this multi-index. So west wind has 2 points of connection, TWF 12 has 2 points of connection. Okay. Any questions? No. All right, so now we want to read this data frame back in. So remember, most of our reading of Excel, we've just got one row of headings, and this one is going to be a bit different because we've got 2 rows of headers. So here's the help for PD Read Excel. We're going to read it in. The file name is going to be df kilowatt-hour.xlsx. The sheet name will just go by default, it'll be the first one. The header, and this is an important one. If a list of integers is passed, these row positions will be combined into a multi-index, which is exactly what we've got. So it took me a while to find that, but that's where it was. It was sitting there in Read Excel. So our header is going to be in rows 0 and 1, and our index column is going to be 0. I think that's all we need. And xlsx, yes, I've got to say the engine, of course. So that looks pretty good. Let's read that back in, and of course you've got to do round these times in the index. So we'll look at the solution here. Solution 6 does the same thing. Yep, that's all exactly the same, in fact. And then it does this rounding the index. So that's how you round the index. You say dfread.index, so your new index you're going to replace with the old one with. It's going to take the old index and round every element in it to the nearest second. So let's have a look at that. dfread, and yep, our index has got nice rounded times. So all good. All right, so we had a look at the spreadsheets that we were producing by saving these data frames, and they were a little bit ugly. The columns were all narrow, so it was hard to read the data, and we didn't have any formatting in them at all. There was only one worksheet in the workbook, so there was no other information available there. So if we want to format it, I've looked at both OpenPyXL and xlsx Writer. Both are supposed to offer formatting options, but it's pretty hard to work out how to use OpenPyXL to format in conjunction with pandas. So I tried using XLS Writer, and I got much better results. So I've given an example here of a real-world solution to saving this data. Some of the things that I'm going to do, I'm going to supply a format that I want all my dates and times to be shown in. And so to do it, I create this line here, and this is all explained on this link. I've provided a link how to do it. So we say pd.xlwriter is, and then we put the file name and what the engine's going to be. And then once we've done that, we can start making changes. So we can do our data frame to Excel and to that writer, and then we can make all these other changes. And it's not till we hit writer.save that it creates the spreadsheet. So all this stuff is kept in memory. So what we can do, we can name the first sheet to my report. We can start creating some formats, and to create formats you have to create a workbook, and add the format to the workbook, and then you can call that format later. So writer.book gives you access to that workbook. I've created a format here for dollars, for just standard numbers with 2 decimal places, and a text. I decided maybe I'll have some bold and some aligned left. I can call up a worksheet by that name, and I can set column widths on that, and you can even set column formats. So I said column B to I is going to be 12 characters wide, and it's going to be formatted in kilowatt hours. J, even though it's a kilowatt hours, I decided to show it as formatted in dollars, just to show you can do that. Freezing panes is a thing I like to do in spreadsheets, so I've called that function there, and it's going to freeze it on the cell position B4, and so B4 will be the top left corner of the moving area, and everything outside that it will be frozen. I then created a new worksheet in that workbook, which I've called page 2, where I've just put in some text, and I've given that a format. So that's how you write some text and give it a format in the same line. I put in a number, and I've also, you can even do formulae, and we'll save that. So this is really just a demo, proof of concept, how to do it. If you have any questions about it, feel free to ask. I haven't set any tasks on this, but it certainly have a go at it, because it really makes things look a lot better. Especially saves you having to reformat your data frames that you've written out to Excel spreadsheets, and then if you go and format them before you hand them out to anyone. So let's have a look. What do we call it? Pretty.xlsx. There it is. There we go. We've got some nice wider columns. That's looking better. We've got our dates and times in that format that we specified. Everything's now to 2 decimal places, so that looks good. We've even put dollar signs in on the last column, and it's even, we've put formatting so that if the numbers went negative, they'd show up in red. So just all the features that you can do in Excel formatting. I think you can even do conditional formatting. On page 2, we've got our text, our number, and our formula. Now, if you're in Excel at the moment, that formula should have automatically calculated and given you the value 9. It uses an Excel flag, and LibreOffice doesn't really take notice of that flag at the moment. So if you're in LibreOffice, you have to do this recalculate hard, Control-Shift F9, which will recalculate every formula in the workbook, and there we go. It's now showing the value 9. So that's really all that we've got tonight. I'll just close all these up. Feel free to ask any questions. I'll be listening for a little bit longer tonight, but even if you ask on the Slack channel anytime during the week, and I can have a go at answering it, or someone else in the group, they will monitor it, so they could also answer it as well. I hope you've enjoyed the this meetup. Click subscribe if you and click on like if you liked it. So I'm looking to get to 100 subscribers, and I'm almost there. So it's once I get there, then I'll be able to get a better channel name, and that'll make it easier to get new subscribers after that. Peter says, who would have thought that time zones could be so much fun? And that's exactly right. It's just and who could have thought that daylight saving could have introduced so many problems? I've known of some companies that put their servers on daylight saving time, and it's such a problem that they actually turn their servers off at each time, once in April, once in October, when the time zone changes, just because it can cause so much such hiccups in time zone and how servers operate. I really do not understand why they would even think of using a daylight saving time as the local time of a server. All these files, these are the original files, and we've also got our GitHub, so you can go there if you need. On the GitHub, I put a Python version of this Jupyter Notebook, so for people who don't want to use Jupyter Notebooks, you can just run it straight in Python from the command line, or in IDE such as PyCharm or Visual Studio Code, and it will do all the exercises, and sometimes showing you the different ways of doing it on in Python than you would if you are using Jupyter Notebooks. Okay, next week I'm hoping Arun is going to be taking the session, and the week after that, so he does more the machine learning, although what we've done tonight using pandas is very good tools in data science, and so it really will help you, anyone doing data science. The week after that will be for absolute beginners, which we do the first week of every month, and Annie will be taking that one for the first time, so hopefully she'll be at the correct level for the beginners. Maybe I feel sometimes I go in at too high a level because I just get so excited by it all. So that's all from me, and until next time.